So far in this class, when I've picked two elements to put together to make a compound, I have chosen a metal, probably from the far left side of the periodic table, with a nonmetal from the right side of the periodic table. And why do I pick those? Because it's pretty straightforward. Metals tend to lose electrons and become positive ions, and nonmetals would tend to gain electrons and become negative ions. And so if you have a positive ion with a negative ion, they're going to make what we call an ionic bond, and that's going to be what the compound is made of, a positive ion and a negative ion. But what if things aren't so straightforward? What if we just have a bunch of metal atoms hanging around, like in steel? Steel is mostly iron atoms and some carbon is thrown in, but let's forget about the carbon for right now. So what happens if you only have metal atoms around and they tend to want to lose electrons? What happens is this. These metal atoms, the nucleus, right here is a nucleus, and if we have a whole bunch of these things, we call them nuclei. The plural is nuclei. These nuclei get locked in this kind of this structure. We call it a lattice. And since they tend to lose their electrons, the electrons are just kind of bopping around. So like right here, here's an electron. He could be here for a minute. He might buzz over here, might go over there. All these electrons are all over the place. Matter of fact, you hear some people use this term, a sea of electrons. This is called a metallic bond. Not something we get into much in this class. I just wanted you to know that it's out there. Where I really wanted to go in this video was what happens if you have nonmetals with nonmetals. What's going on here? Nonmetals with nonmetals. I think the best place to start, is with hydrogen. And you know that hydrogen is atom number 1 because it's got 1 proton. Mass is 1 because probably no neutrons. But what you've got is this nucleus, this 1 proton, and you've got this 1 electron all over the place. Usually we tend to just draw it like this, just for simplicity's sake. Here's our 1 electron buzzing around the outside. What if I asked you, you've got this tank that's marked hydrogen. What if I asked you what was inside of this tank? What's the formula? Do you think it would just be a bunch of these little single atoms bopping around? That would be a good guess, but the truth is, no, that's not what happens. Let's look at another picture. So hydrogen atoms, you guys already know, and this drawing's a lot better than mine, there's this 1 proton and there's 1 electron buzzing around the outside, and there's room for 1 more electron. So if you have 1 hydrogen atom with room for 1 more electron, what happens if you have 2 hydrogen atoms? Since they both have room for 1 more, what they can do with those 2 electrons is they can share them. And if they share them, you get what's called a covalent bond. I think of it as kind of a partnership. What holds it together? Well, this proton is attracted to this electron. This electron is attracted to this proton. So we get this electrical attraction between both of these electrons and both of these protons. So this proton is attracted to this electron and vice versa, and same thing with this other one. So this electrical attraction here is where the bond is. So that's the chemical bond holding them together. So who does this? Like we said, this is nonmetals. And somebody made this awesome picture. And here are the big 7. There's hydrogen, gets together like that, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those are the 7 that get together in pairs. We call those diatomics. Di for 2 and atomic for atoms. So going back to my question down here on this first page, what's inside this container of hydrogen? What's inside there is little particles, but each little particle of hydrogen is made of 2 atoms bonded together, and we call those molecules. Covalently bonded. And whoever made this picture showed us a couple other ones that are kind of cool. If you find phosphorus, phosphorus actually gets together in groups of 4 atoms. So they make these neat little pyramids. Sulfur is also kind of cool. It looks like a crown to me. Sulfur atoms get together in groups of 8. You can't see it because it's a 3D drawing here, but they get together in groups of 8 atoms. So if you have some pure sulfur, you're actually seeing molecules with 8 atoms each. If you look on my periodic tables that I keep by my quiz computers, you'll notice that these elements that are diatomic have little d's by them, so that will help you. And I think I also put a little 4 here and a little 8 here for phosphorus and sulfur. So before I close out this video, I'm at 5.5 minutes. What if I gave you a sentence like this and I asked you to turn it into a chemical equation? Sodium and chlorine combine to produce sodium chloride. What would you write? Well, sodium is Na, and is plus, chlorine is Cl. Combined to produce, that means we've got a reaction, so that's an arrow. And then sodium chloride, we know that sodium is +1, makes a +1 ion, and chlorine makes a -1 ion. So it's just NaCl. But what's wrong with this? What's wrong with this is I forgot something. I forgot that chlorine doesn't exist as solo atoms. Chlorine exists diatomically. It exists as pairs. So to make this correct, I need to have a little 2 right here. So closing in on 6.5 minutes, I think that's a good place to stop.